Yes. Immediately, we will start the first round table, and I will call here Cordelia Schmid, Thierry Bauchon, Éric Monchalin, Luca Nacsa, Henri Sanson. Will you please join me here? Asseyez-vous. Nous sommes voilà ici et voilà. Vous partagerez les micros, il n'y en a pas un pour chacun. This roundtable is AI as a rupture technology. And of course, I asked all our panelists what they thought about this very sentence. Cordelia, we'll start with you. You're Director of Research at INRIA Grenoble Rhône-Alpes. You are an IEEE Fellow, which is an honor, since 2013. You have been editor-in-chief. You still are the editor-in-chief of the International Journal of Computer Vision? It stopped. Well. And of course, it's a position which shows how renowned you are worldwide. You have started recently to work part-time with DeepMind, a Google subsidiary, and you count numerous prizes. I'm not going to tell all of them, among which Grand Prix INRIA Académie des Sciences 2016. So, Cordelia, when do you point the rupture in your field as a researcher? Something like 5 years ago, or before that, or even more recently? Try it.
Okay. Yeah, I would say, I mean, that's what I told you last night. I would say 5 years ago would be really the point where things started to work much better than before, right? Where you can really pinpoint that now things really start to work, and like things which you could not think of 10 years ago that they would work, they started really to be feasible.
And how would you live this change? Does it create a lot of questions even in research labs, or are they so happy that it happens finally? I talked about the winter of AI, and now it changed totally. And that's the feeling we have when we are not researchers.
No, I think for me it's very nice because basically things really finally start to work. So obviously the techniques have changed over time, but that's normal. And so for me it's really nice that now things which, for example, Bertrand showed this result for video, which 5 years ago didn't really work, but now really they start to work, and you can really use these things and get information out of it and really get things which start to work. And it's not just it works on a few examples, but it really works in general. And so I think it's very nice. And there's still, like, of course, many open research questions, right? So today I would say we have addressed the first level. We can recognize simple patterns, basically. That's what we have today. And the next steps are really to go towards more intelligent systems, right, which can predict things and interpret things and not just recognize simple objects.
Would you say that you're foreseeing the next few years as just, incrementing, changing a little bit things? Bertrand showed that now for face recognition, it's under 3% of failure. How do you picture the forthcoming years? Is it possible, or do you have to count in months, or you don't know what will happen in another research lab?
So I think for now people are more doing this incremental things. So basically that's kind of the current trend, and what people are now looking for is to move to the next level, right? To have really this more intelligent systems and not just recognize. So ImageNet, what Bertrand showed, is just classifying images into different labels. And so that's far from really understanding what's in the world and what is in images. And so now basically the next level is really to interpret what's going on, right? One example he showed was this image captioning, where you have an idea what's going on, but ideally you would want to go much further and really say what is the intentions on somebody and who is interacting and what's really the content. For example, just transcribing a full video with what's in there, that's something which today is not possible. If I tell people it will be possible in 5 years, people also start to question it. So that's kind of one of the challenges we have. And then the other thing which you mentioned is to go up to 100%, right? That's the thing which you really want, which you cannot guarantee today, and to explain what the decisions are. And that's something also which is super important and is completely open how to do this. And I think these are the things which in the next 5 years you want to address, and then in the long term you want to really have more intelligent systems, right? Things which can learn over time, which do lifelong learning and things like that. So that's actually the things, the challenges which are open.
So we have to follow what happens in the next 5 years, which seems very long in a way. Luca Nacsa, you're CEO of Neovision. You founded Neovision in 2014 as a consulting company in AI. And you say you help all sorts of companies of all kinds. One of your clients is Schneider Electric, but maybe you could talk about others. You're an official consultant in AI for BPI France. It's still the case?
Yeah, it's still the case.
I wondered, you say that you came from a lab, from a research lab, and then you started a company. And you say that for your clients, you have ready-to-use technology. Is it really true?
There is a lot of work to create ready-to-use technology. First of all, we need to very well understand the environment, the constraints, the jobs of our clients. It's very important to understand what kind of data can be used to train the artificial intelligence. And this is a lot of work, and that's why we do consulting. We just don't just do software development. You cannot just tell someone that you can create an artificial intelligence from nothing. You need data, you need to understand what is the problem, and if you have the data that can represent the problem. So,
do you think your clients know exactly? Well, maybe they know what they want or what their goal is, but do they know really what it's all about, or do you have clients who really are lost, and it's a rupture technology for them?
It's rupture technology for them too, I guess. I have a lot of different kind of clients. I have startups that know very well new technologies. I have small to big companies, and they all have a different kind of maturity with this technology. So we need to help them to understand what is the process to create an artificial intelligence, what kind of data we need, what kind of bias we can find in the data. And so it's...
Did things change in 5 years since you started?
A little bit, but not so far.
So you think it's a bit too slow?
Yeah,
People
I guess,
don't get acquainted with the new technology rapidly enough?
For sure, there is a lot of new things that come in artificial intelligence. In scientific paper, you find a lot of new things. The last one in the 4 years is generative adversarial network, for example. If you know the website this person doesn't exist.com, you can find images of face of people that doesn't exist, and it's very convincing. So right now we have new kind of artificial intelligence that can generate data, and this is only one example of very impressive new technologies that we can create. And people need to understand what use case you can create with this technology. So we need to help them to understand what we can do with technology. So
give us precisions about your your firm. How many are you now? And how many will you be in 1 year or 2 years?
I can understand. I can answer the first question. We are 19 right now. We was 10 last year, and I don't know how many we will be in 1 year, but I guess something like twice the number. But it's very difficult to say because I don't want to explode in the growth of my company. Right now I want to be very sure to have to hire the good people and to form them.
Is it difficult to find them, or here in Grenoble you have no problem?
In Grenoble we are very lucky because we have a lot of good schools like NCMAC, for example, which is my school. It's not why I guess it's a good school, but it's a fact. People that come from this school are very well prepared to understand mathematics, statistics, machine learning, and informatics. So we have a lot of we have a good chance here to have a good data scientist to find this kind of profile. But this job is very new. We need to form the people to understand all these kind of mistakes you can do in artificial intelligence projects. So right now the market is very hard to find good people.
So here is the AI as a rupture technology. Eric Monchalin, you're vice president, head of machine intelligence at Atos.
Yep.
Until now, it's okay. It's okay.
Yeah,
it's
it's
correct.
okay. Yeah.
It's correct. And you're responsible for solidifying new technological and business directions for big data and security global business line. Wow, what a lot of work. You had numerous R&D positions in several companies, and you managed multi-tens billion euros project with big teams. And you say that you're focused on customer wishes. So for you, when we prepared this roundtable, you told me that it's less a rupture than a continuum. That's how you see AI with Atos.
Yeah.
With 3 stages.
Yeah, okay. So the first point is if you are looking this story from a business perspective and a company perspective, the beginning of the story is starting from, I would say, the big data revolution, moving the data from the silos to a joint repository, offering the ability to correlate, and it, as Bertrand shown, you have to take care when you start to correlate data because you could make a lot of mistakes, but also to link all of these data together to move from data to information, and then from information to knowledge, and to enter in the artificial worlds. And when you start to have all these data, you can start to run analytics, and moving from data to information to knowledge, you start to enter in the artificial worlds. Artificial intelligence world. So from, I would say, a global perspective, it's more continuity than a rupture. But if you are looking what happened for digital revolution, we had the, I would say, first digital revolution in the 70s, a long time ago, with data driving processes. And it was the time for ERPs, SAP, etc. And it was the beginning of business intelligence, which is the ancestor of big data, but with a big constraints creating all these data silos. And then we have the second revolutions, data driving customer experience and customer satisfactions, and it is well mastered by all GAFAs. We mentioned US one, but we don't have to forget Alibaba, Baidu in China. So it's not only US, but also China. It's fully linked to retail worlds and to web sale mechanisms. And in terms of research, it's really a key point for all these companies. And I really feel that for Europe, especially, it's very, very difficult to recover and to be at the state of art as this company and to compete in the research field. Now we are entered in a third digital wave, which is data-driving businesses. And it means also that these challenges are coming out of the retail world to go within B2B, business-to-business activities like industry, agriculture, healthcare, all the new field you mentioned. And depending where are these companies with all these revolutions, it could be a continuity or it could be a big rupture or a big disruption. So from us, our own standpoint as a company is a continuum. But for our customers, some still have silos. Some are just jumping in data analytics. Some are already managing knowledge, etc. So in the past, I would say, how to take value from data information to conduct their business, there are very different distance from what we could do today from a technology standpoint.
Yeah, you mentioned that even big companies can be very vulnerable. They don't, maybe they don't really know at what stage they are.
Yeah. The topic there is that for a company, most of the time, as long as you are not in a big danger in front of your company,
you wait.
You are waiting.
Yeah.
Now you mentioned Uber, Booking, Airbnb, etc. We are seeing companies disrupting their worlds, and such story could happen in every field today. And if you are not prepared, you will not go fast enough to survive. So you are a big company, but with, I would say, agile feet. So it's difficult situations, and it starts to be realized, but not so enough. And I think I am back to what Luca was saying. Yeah. Some companies are very aware and are still working. Some are not checked enough, I would say, to start their road on this story.
And maybe you share the same experience, that some people might even ask you, what can I do with my data? They don't even know how to capitalize on that. Yeah,
but I would say that is a very bad question. Because if you start your thought by what can I do with data, you will fail. Because the best question is, what are my challenges? Where I have to improve, and then how I can do it, and will my data help me? And there is a good order to ask you the right questions.
And for you, AI is a mean, in a way. It's not the goal.
It's a capability to help you to achieve your objectives.
Okay. Thierry Bauchon, you're director of AI strategy at STMicroelectronics. And beforehand, you were R&D director for more than 2 decades at this same company.
Yes.
Yeah. And you have an extensive experience in semiconductor industry, obviously, and organizing teams for research. I hope in a strategic manner. I think that's what you're looking for. So, you used that sentence, and you told me that even 1 hour ago. ST enables AI on the edge. That's your motto.
Absolutely.
What does it mean for the audience? What does it mean, enables AI on the edge? On the edge.
Yeah, first of all, on the edge might be having a different meaning, whether we are talking with my predecessor or whether we are talking with what I call the edge. For some people, the edge is just the gateway. That means this server that is making the link between the cloud and your premises, or if you are an industrial, or your home, if this is your home gateway. What we call the edge is rather the object. It could be the watch, it could be the car, it could be a camera that is making some smart city duty or things like this. And what is interesting is that we are rather addressing AI from a different point of view than what we have been hearing so far. That means instead of talking about big data, about cloud-based intelligence, we are talking about bringing this intelligence to the object. That means very close to the sensor. The fact is that we want to make intelligent the object. And I believe that there is a very nice definition of what is the intelligence. This was made by a person called Niels Nielsen, and it was at the end of the 50s. And this person said the intelligence for an entity is just this ability to understand the environment and react, to behave within this environment. And this is what we want to do. Enabling the AI means that we want to help our customers to make existing application or to develop new application, bringing more intelligence to what they do. Typically, we have an example in industrial with Sagem, for example, where we have been able, on an existing solution, to bring some intelligence to make this application more powerful, more efficient. And while we do this, we start to bring some tools that will enable someone who has a pre-trained network to map it on an existing microcontroller from ST.
So what you mean, and you gave me this example also, is having sensors, intelligent sensors in factories to predict failures, for example. So that's what you working on.
That one example that is making predictive maintenance. By the way, it's not necessarily mapping a neural network. It's more machine learning, I would say traditional. It's clustering, but yes, you can learn what is actually the good way one machine will operate, and you can detect when something is becoming abnormal, and then flag that there is probably something wrong that is happening. This is one example, but we have, of course, plenty of different ones.
That's what you would call smart industry. That's the new trend. But you have everything, smart city, smart home, but everything will be smart.
Yeah, we are smart everywhere. And actually, we are smart everywhere because our belief is that, ST wants to make your life augmented. So we want to, wherever there is some electronics, we want to bring something and add some features, some capability, enhance what is doing. And the way we want to address this, although, we're very involved in autonomous driving through our automotive division with some big names in this arena, but we had decided to come from the object because today we are the leader in the general purpose MCU. We have more than 60,000 customers in the world, and we believe that we can leverage this presence to come, demystifying somehow AI. AI does not necessarily require that you have big machine, that we have teraflops available engine. We are coming from something where you can run some existing application on an MCU, and this is what we are bringing.
Before giving the floor to Henri Sanson, if you have any question, I will take some question afterwards. So prepare them, think about them. Henri Sanson, you're Director of Research, would I say Data and Knowledge? That's how you call it?
Yes.
At Orange Labs. And you lead the technology research in the areas of AI, data science, decision support, blah, blah, blah. Plenty of things, mathematics, audiovisual. How do you manage to do all these things at the same time? How many are you? Tell me again, in your Orange Labs?
We are a little more 100 researchers on these topics, which is really mathematics and technology focused.
And young people, about 140 in thesis or something like that?
Yes, this concerns the research, Orange research overall. We have 140 PhD students present at a given time, but for covering all the topics, network research, IoT research, also sociology research.
And for you, the AI is linked mainly to conversational natural language, optimization of the auditory recognition. These are your main aims, your main objectives and difficulties.
Well, in fact, we have different objectives, and we work on different technologies or solutions. In fact, when we speak of AI, in fact, we mix very different things. In fact, we have what people call data mining, data analytics, which have been done for many years. In fact, it
and
consists.
we called them with other names in the old days. No. Data mining.
Data mining is still used.
How old is the expression? 5 years, 10 years?
Yes, it's more than
20 years. Cordelia, 20 years. It's old. Yeah.
Yes, but maybe more than that. Today we speak of data science. It's more elegant, but we have to be aware of the distinction. You have data mining on one side, and you have what I call anthropomorphic artificial intelligence, and what market player call cognitive services, which is speech recognition, natural language understanding, natural language processing, conversational agents. So this AI tries to mimic, to replicate, in fact, the cognitive capabilities of human beings. When you speak of data mining, you want to address some specific business problems. So you collect the data, you interview the business expert, and you build, in fact, a mathematical model which is dedicated to solve this problem. For instance, you want to do some churn prediction, or you want to predict the appetence of your customer for some of your products you sell. This is really data mining. So we have been doing data mining for years, both at the level of research, but also at the operational level. First, we have started on marketing. Marketing was one of our first internal customer for data mining solutions, and now it is spreading for fraud detection, for network diagnosis. And we have been researching for more than 15 years on anthropomorphic AI, on speech, on visual recognition, on natural language understanding, and it is clear that there has been the revolution of deep learning that really boosted, in fact, the performances, and now it has become, in fact, really usable in our real services, in fact, which was not possible, I would say, 5 years ago. We have to be aware that 5 years ago, we had to design use case specific speech recognition, for instance, that was able to recognize about 2,000-3,000 of words. Now we speak of millions or dozens of millions of words that speech recognition, our own speech recognition, is able to recognize. So
what you're telling us is that that change happened in 5 years only?
Yes, yes. Yes, I can give you some anecdote. So we develop our own technology, but we also regularly do benchmark of external providers. And in 2015, in fact, we measured the performance of Google speech recognition for voice interaction. And between the April version and the October version, it has gained 30% in word error rate. It's absolutely amazing.
Something Luca mentioned, and maybe it's the same for you, and I don't know for Cordelia, is the rate and the acceleration of studies. In your field, do you cooperate with other research labs, academic ones, and your competitors? In fact, the Facebook or Google, they have open algorithm that you can use. How do you interact with the, I would say, the world ecosystem?
Well, we are doing, like I suspect everybody is doing, that we of course leverage all these open source frameworks and all these data sets, because data is very important. And we also collaborate selectively with some academic teams, and maybe essentially with academic teams. With industrial teams, it's more difficult because of the problem of data. Data sharing is very complicated, in fact. So.
Okay. Are there any questions? And if there are, please raise your arm so that I can see you. Well, either they're asleep or bored. No question. How can that be? Okay. So I will... at last. Thank you.
Listening to you guys, except maybe for Thierry, how much does hardware architecture matter to AI?
Who wants to answer? Eric Monchalin.
I believe it's, and maybe you will have some comments, but I believe it's a big challenge even today. We mentioned that we did a lot of progresses these last 5 years, and one of the reasons is the progresses of the computation capabilities. Now, the question is, artificial intelligence is a lot of data, so it's how to avoid to move data to computation and rather move computation to data. And I feel it's really key for the future. And we still have a lot of research in front of us, and even moving the paradigms, we are using still the beginning of the IT. And as it has been mentioned, I feel that it's key that the intelligence will move on the field, because one more time, it will not be affordable to move data to the computations. And it is one reason for which I fully agree on what has been done, what will happen on the field. And there is still a big challenge to have the right architectures to run this type of algorithm to run artificial intelligence. But I feel that this distribution on the field is really key for smart industry, Industry 4.0, and it's a real opportunity for Europe and France in particular to reindustrialize our country. So there are very big challenges there.
Well, I believe that hardware is extremely important. We have seen that people today, they try to match AI on FPGAs or CPU or GPUs. Actually, some have been extremely successful on GPUs. But clearly, there is a need to make the most appropriate hardware to match the way we want to implement the algorithms. And necessarily, it will be a mix in between hardware and software. So the partitioning is extremely important. And what is also extremely important is that we are talking about applications that are performing and that are making things that look to be magic or fantastic. At the end of the day, this consumes also a lot of energy. So all of the challenge will be also to make sure that we can reduce this. And one of the targets that ST is having is to bring this to the object and make this possibly battery life. So therefore, the hardware will be extremely important. I believe you're well placed to address this challenge as well, Loïc.
Another answer or another question? Another question. Here, over there, fourth row.
Thank you. Algorithms are a main part of the intelligence artificielle, together with data and so on. Do you have any strategy for protecting your algorithm through patent, secret, open source license strategy or so on? Could you give us some view about your protection strategy?
Who wants to answer? Eric Monchalin?
So on our side, we are not necessarily creating so much algorithms. We are mainly creating, I would say, cooking books to how to assemble algorithms all together to solve some customer challenges. And yes, for sure, we are patenting and these algorithms because it's part of it's a way also to protect our businesses. Nevertheless, we have, I think, most of the actors in this area a strong open source mindset. Most of the frameworks of the algorithms are available from open source, coming from very large companies like Google, Facebook, or others. So a lot of our stuff is open source. But at some point, when we create, I would say, a strong value from the way we do assemble all these technologies to create value for our customer, we are patenting for sure.
Well, it's a very good question. I participated last week to a seminar dedicated to IP protection and which focused on AI. And for me, it's still an open question how to protect AI with either secret or patent, because you have many factors against intellectual property protection. Because first, as you said, there is this fashion of sharing. In fact, people share share software, they share data in some area. The performance of a technology is a combination of algorithm and data, and there is a so amazing rhythm of progress in AI, or at least in some areas of AI, that we are almost sure that the principle that we are implementing today will be obsolete maybe in 2 or 3 years. So what does it mean to file a patent that is supposed to last for 20 years if in some within a few years, in fact, it will be completely obsolete? So it's an open question.
Cordelia, seen from a research lab, does this question is this question a needed one, or you don't patent anything?
No, we don't. In general, we don't patent, and my personal philosophy is to put everything open source, because that makes your work much more visible, right? If people read your paper and can reuse the algorithm, they see that it works, then they're much more likely to reuse your approach. So for us, it's actually a good publicity to put things as open source.
Even little bits of code inside the algorithm? I'm asking maybe a silly question. Even something that you don't want to share? No, maybe not.
No, I think
maybe not in public
not
labs.
In the spirit. I mean, maybe some people do, because they kind of, it's good to keep some advantage. But in our case, it's the only thing is, if there would be some industrial constraints or it's an industrial project, then obviously we have to kind of coordinate with the industrial partner. But otherwise, if it's just my choice, I would just say put it open, and it's good for the progress of the community as well, because you don't want to hold back things. And the same thing for data. Obviously, it's always more tricky, because data, you have all these copyright issues, you have all these protection mechanisms, and so you cannot put any data just on the web. But if possible, then yes, again, it's something which is super important also to have this publicly available benchmarks to compare algorithms. So I think that's something everybody agrees on, and it's getting harder and harder these days with all the protection laws, right? You have to be super careful. You cannot just put any images on the web and say they're usable. So,
Thierry Bauchon, you wanted to react, and Eric Monchalin, I think you have to add something.
Yeah, maybe one point is that I believe that this is not necessarily the algorithm or the networks that need to be patented. To me, what will make the difference is the way you implement that. And the way you implement that, back to the question before, was what kind of hardware you are going to implement. This you might patent, or you will not patent because you want to keep it more secret. This will be also the quality of the data and the quality of the learning that you are going to make. So I believe that what will make the difference is not necessarily the algorithm, and maybe we are not inventing that much new algorithm today, is really the quality of the way you are going to implement. And of course, if you want to implement this on the object, you will have also to consider all things that are linked to embedded way of doing things. Again, the data is very important. And one other complement is that we were talking about accuracy, and I believe that we are not necessarily going to look at the biggest accuracy, going to the 100%. Maybe we need to find the right trade-off, and again, what will make the difference is which accuracy you can reach that will fulfill the need of your application, but will make that your power will be reduced. Because once again, our target is to make this as low consumption as possible.
Eric Monchalin.
Maybe one more comment, because there is not necessarily an opposition between, I would say, patenting and having an open source approach. And quite often we are patenting capabilities we are pushing in open source. And why? Because as Cordelia mentioned, sharing this area is quite important to move faster and faster. And you can patent to attack competition, or you can patent to protect you against competition, meaning that when you are attacked by someone, most of the time in your own patent portfolio, you can find out some patents that have been violated by this competition or competitor, and you can enter in negotiation. So depending on how you do use patents and what is your strategy, there is not necessarily opposition between open source approach, sharing approach, and patenting.
Now, I think we have to wrap up, unless you would have a final remark, something you really want to share with the audience and then, well, thank you very much. I think we have to thank our panelists. Thank you. Je ne sais pas.